The James Webb Space Telescope has just photographed something absolutely marvelous. Lights that seem to be shining like a metropolis were seen from a location in space approximately 4 light-years away. This serendipitous sighting has reawakened the interest of the world in the hunt for extraterrestrial life. The telescope was trained particularly on Proxima Centauri b, the nearest known exoplanet to the solar system, where it observed peculiar bright flashes. These sparks of light have opened up broad speculation. Are they proof of an extraterrestrial civilization? Scientists and the public have been captivated by the prospect of life elsewhere for decades. Any scientific lead suggesting there might be something out there has always generated excitement and optimism. And now the James Webb Telescope has yielded one of the most powerful hints ever, proof that could indicate intelligent life somewhere in the universe. While sweeping across the depths of space, it detected strange light activity on Proxima Centauri b that looks similar to artificial city lights, a finding that has made the scientific world go gaga. This could be one of the breakthroughs researchers have long anticipated, hinting at the possibility of organized intelligent societies beyond Earth. These distant lights, located an incredible 4 light-years away, have left NASA engineers in awe. They wonder how long such phenomena have been occurring, invisible to us until our technology reached the point of being able to detect them. Others even wonder if civilizations on such a world might be older and much more advanced than ours, possibly able to construct infrastructures and power systems that shine so brightly they can be seen across interstellar distances. Proxima Centauri b was called a very complicated planet by David Kipping, an astronomer at Columbia University. Unlike most rocky worlds that absorb sunlight and emit energy in infrared, this exoplanet displays different behavior, largely due to its unique relationship with its star, Proxima Centauri. The discovery highlights just how vital the James Webb Telescope has become in space exploration. Its infrared sensitivity was instrumental in detecting the strange patterns on Proxima b, patterns that might reveal more about the planet's atmosphere and surface features. What makes it more intriguing is the potential that these signals are not haphazard but rather repeatable patterns of light, something more akin to purposeful energy consumption. Researchers will utilize the telescope's ability to observe the exoplanet in more detail, even to determine if it could be habitable. Since the telescope excels at picking up dim light in the vastness of space, it's the perfect tool to decide whether the city-like lights on Proxima b's dark side are real evidence of artificial constructions. If these do come from civilization, they could indicate great-scale energy use, maybe a planetary power grid or vast settlements grouped around the surface. What makes this particularly interesting is that the telescope can see artificial light sources within a very narrow frequency range, much narrower than the natural emissions of stars. This enables the selection of scientific signals from the background noise of space to enable astronomers to distinguish between natural and possibly engineered planetary processes. Proxima Centauri b, as is the case with Earth, experiences a cycle of daylight as it orbits around its star. The planet also experiences extreme temperature changes that will largely depend on if and when it has an atmosphere. Without it, the star-facing side would heat up to scorching temperatures, and the other side would plummet to freezing. Such fluctuations in heat patterns are precious tips to scientists who are attempting to determine what kind of climate there is on the planet. Using its infrared imaging capacity, the James Webb Telescope can observe Proxima b's heat output, providing critical information regarding its composition of atmosphere. This is crucial since the existence of life, and particularly intelligent civilizations, rests substantially on whether or not the world is capable of sustaining conditions stable enough to harbor biology and technology. Coincidentally, the telescope's orbit around the Earth coincidentally well fits Proxima b's orbital period, allowing researchers a chance to monitor its day-to-night transitions every 11.2 Earth days. Every orbit provides new opportunities to contrast the brightness on the day side and the night side of the planet, providing scientists with further information about whether the unusual lights are in line with energy consumption or man-made structures. If the planet is found to have an atmosphere, the next mission will be to examine its chemistry in terms of its gaseous composition, looking for signs of life, like oxygen, water vapor, or methane. While the James Webb Telescope is capable of studying some atmospheric gases such as water vapor, carbon dioxide, and methane, it is not strong in detecting free oxygen, an important sign of life. Nevertheless, it can still seek out associated indicators such as ozone, which can also indicate a habitable environment. And the scientists keep probing deeper into the data, searching for life elsewhere in our universe, slowly getting us closer to finally providing an answer to our eternal question: are we alone in the universe? There are skeptics among researchers who indicate that the lights could be natural, like aberrant reflections of starlight off the surface of the planet or atmospheric discharges like lightning. Others say, though, that the accuracy and consistency of the signals render a natural explanation improbable. What gets the international scientific community all abuzz is that, for the first time, we are seeing something that definitely falls within the realm of a potential technosignature, a signature of advanced extraterrestrial technology. To be sure, the telescope can only closely examine a few nearby exoplanets. For more detailed study, astronomers are looking toward future ground-based telescopes such as the Extremely Large Telescope, ELT, scheduled to come online by 2028. The ELT is intended to provide significantly sharper and more complete observations of exoplanet atmospheres, providing insights that can't be fully addressed by the current generation of space telescopes. With its record-breaking resolution, it may verify whether Proxima B's city-like lights are actual or an illusion of cosmic noise. Meanwhile, the James Webb Space Telescope is still one of our finest instruments for observing remote worlds, even with its imperfections. It continues to return vital information that keeps us refining our knowledge of what might be out there in the universe beyond our solar system. Looking to the future, scientists are also developing next-generation telescope technologies that will bypass the problem of starlight. One of the major hurdles in the observation of exoplanets is that stars burn so intensely that they overwhelm the glowing reflected light from nearby planets. To circumvent this, scientists are creating ways to filter out the light from the star, similar to holding up a hand to screen out the sun so you can observe more clearly. One of the promising solutions is the coronagraph, an instrument inserted within telescopes to shield direct starlight while permitting light from planets to enter. Coronalabs bend the light waves, minimizing the glare and allowing for the faint light from exoplanets to be more easily detected. Another promising idea is the Starshade, a huge flower-patterned spacecraft that travels tens of thousands of kilometers ahead of the telescope. By physically shadowing the starlight before it even reaches the telescope, the starshade only permits the light from planets to be observed. This might be particularly useful for the examination of planets within the habitable zones around their stars, areas where water and perhaps life may be present. If urban-like lights actually do exist on Proxima b, these technologies may one day take sharper and more direct photographs of them, transforming speculation into fact. These cutting-edge technologies need an unprecedented level of accuracy. To give a specific example, positioning a starshade precisely requires ensuring accuracy down to minute fractions of a millimeter over vast distances. And that's just the beginning. These systems need to be energy efficient, small enough to send into space, and robust enough to withstand the harsh conditions of space travel. If successful, these technologies might enable us to detect biosignatures, chemical signatures of life on distant planets. The existence of certain molecules such as oxygen, methane, or water vapor in particular proportions might indicate biological activity. If these biosignatures match artificial light, it would make the existence of intelligent life more probable. Researchers are also striving to directly image these distant worlds with greater detail. Next-generation telescopes could feature adaptive optics capable of compensating for distortions induced by Earth's atmosphere or the motion of the telescope itself. Coupled with light-blocking technologies, this could make it not only possible to detect exoplanets but also to image their surfaces and learn about their climates. Picture being able to gaze upon Proxima Centauri b and determine if the lights of illumination are formed in grids, clusters, or outstretched networks upon its surface. Such a view would turn science fiction into science fact. The construction of the next generation of space telescopes is a giant step forward toward answering one of humanity's greatest mysteries, whether we are alone in the universe. As our capability to monitor far-off worlds grows stronger, our opportunity to find extraterrestrial life also increases, an accomplishment that could revolutionize how we perceive ourselves and where we fit in the universe. Proxima B's lights, whether they are man-made or natural, have previously created debates in universities, governments, and even among regular individuals intrigued by the universe. They remind us that the universe can still be full of secrets that contradict our knowledge about life, technology, and civilization itself.